You are looking at the representation of one of the largest objects in the known universe, the Saraswati supercluster. This thing is so huge that even light takes 650 million years to go from one end to the other. But what is Saraswati made up of? How was it discovered? And how far is it away from us? On the largest scale, the universe looks like a giant cosmic web. First, stars, including our sun, are grouped into galaxies. Then, the galaxies are clustered into galactic groups, bound together to form galaxy clusters. When these galaxy clusters occasionally merge, they create the largest structures called superclusters. They can contain baryonic masses of up to trillions of times the mass of the sun and stretch over tens to hundreds of megaparsecs. Thus, they trace the most extensive scale structure in the universe, comprising dozens of galaxy clusters. Saraswati is one such supercluster recently discovered by a group of Indian astronomers from Ayuka and Isar in 2017. This cosmic structure is named after the Hindu goddess of music and knowledge, Saraswati. The supercluster is 4 billion light-years away. 1 light-year is the distance that the fastest entity in the universe, light, travels in a year. It is approximately 6 trillion miles. This means the light we see from the supercluster was emitted 4 billion years ago, when the Earth was in its cradle. You must be wondering how such a massive supercluster was discovered, and what questions and solutions it poses to the scientific community. Stay with me. The discovery of Saraswati was made with the help of extensive spectroscopic observations over a large band of the sky, called Stripe 82. Later on, statistical methods were used to spatially link galaxies, eventually revealing the Saraswati supercluster. It contains more than 40 confirmed galaxy clusters and is surrounded by vast galactic voids. The most massive clusters inside Saraswati form a wall-like array with strong filamentary features, which evolve with time. A supercluster of this size and mass is a prime laboratory for testing Einstein's general relativity and structure formation, and can prove many cosmological models. This makes it one of the largest superclusters to be discovered, and also the furthest, since it lies 4 billion light-years away. Observing it implies looking 4 billion years back in time. According to our current estimates, the universe is about 13.8 billion years old. This means the structure existed even when the universe was about 10 billion years old, roughly 70% of its present age. Now that's a puzzling fact. According to present theories, it is difficult for such a colossal supercluster to have formed so early in the universe's lifetime. Cosmological simulations tell us that finding such an extensive and massive structure is very unlikely. Moreover, the redshift of 0.3 places Saraswati near the region called the cosmic transition, meaning a change from matter-dominated universe to a dark energy-dominated universe. Isn't it just fascinating? Yet another thing connected to dark energy. So what now? You must be wondering what else is left. With great discoveries come great scientific techniques to look into the physics behind them. Discovering more such superstructures can constrain different cosmological models and the power spectrum of primordial density fluctuations, leading to a better understanding of the universe in the past. It provides astronomers with considerable scope in studying the structure formations in the early universe. However, scientists are still following up with the spectroscopic and X-ray observations of Saraswati that are necessary to confirm the supercluster's boundaries and redefine its total mass content. It is a rare discovery, since there are very few known superclusters of this size in the entire universe, leading to the solutions to many mysteries in the cosmos and revealing hidden problems to the scientific community. If you're interested in studying astrophysics at home, Make sure to check out our Basics of Astrophysics series, the link to which is given in the description. This series explains everything at the most fundamental level, from the EM spectrum to telescopes, and from the birth of stars to the formation of black holes and galaxies.